Okay, today we're talking about lesson 7.1. 7.1 is all about graphing exponential growth and decay functions. This goes along with our Pascal 2.5a. Let's talk about exponential growth. All right, what exponential growth is just like this. Suppose that you borrow a penny on a day, and the person you borrow it from says that you don't have to pay them back for a while, but the money that you owe them is going to double each day. Let's take a look at that situation. There's a penny. Now we're going to double that. So on day 2, you owe them 2 cents. On day 3, you owe them 4 cents, and so on. So day 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and so on. At some point here, this is, I forget, day 28 or something like that, you're going to owe them $1,342,177.28. See how quickly that grew. That's what we call exponential growth. All right, so that's exponential growth. And so now, some other important parts of the growth factor, the growth graph, is this line that it never ever crosses. That is called an asymptote. All right. Now, in this case, it says the asymptote is the x-axis, and another way to think about that, in this case, would be the asymptote is y equals 0. It means the same thing, x-axis and y equals 0. And this is growth. Exponential decay, on the other hand, starts out really high and dissipates over time, to where it basically approaches the asymptote but never reaches it. Now, your goal today is to graph these things, and there's two basic ways to graph them. One way is to make a table of values. Our function is y equals 3 to the 2x power. All right, so we'll just plug some numbers in here for x. Let's say x is 0. If x is 0, then what I'm looking at is 3 times 2 to the 0 power. 2 to the 0 power is 1. So that's 3 times 1, which is 3. Let's put a 1 in there. 3 times 2 to the first power. That's going to be 3 times 2, which is 6. Now we'll put a 2 in there. 3 times 2 to the second power. 2 to the second power is 4, so we get 12. If we put a 3 in there, we get 3 times 8. And you can see how quickly this is growing. All right? Now, some other things you can do is put a negative 1 in there for that power. That's 3 times 2 to the negative first power. 2 to the negative first power is 1/2, so that's 3 times 1/2, or 1.5. So if I put a negative 1 in there, I get a 1.5. All right, so this is the old-fashioned method of it. You can also use the graphing calculator. Let's show you how you would do that on the graphing calculator. All right, let's set up. Push the right buttons. Should work just fine. Okay, with our graphing calculator, you're going to want to open a graph and put the function in. 3, 2 to the x power. Push enter and you see the graph right there. Now, the graph is real nice, but you do need to see the values, the numbers there. This will build the table for you. Now, when you look over here on this side, you can see that you've got the same values on this table that you did when we built it by hand over here. So, once you get those values, no matter how you do it, either with the graphing calculator or doing them by hand, you need to get these onto the graph. 0 graphs to 3, 1, 2, 3. 1 graphs to 6, 1, 2, 3, 4, 5, 6. 2 graphs to 12, it won't fit on there. Negative 1 graphs to 1.5, and so on. And you can see, basically, we've got this graph happening right here. It's just like the one on the calculator. Okay, now, so step 1. build your table. Step 2, plot the points and graph. Step 3, I want you to name the asymptote. Now, look at how this thing is approaching the x-axis. Sometimes that asymptote is going to be above or below the x-axis. It may be, up here somewhere that it never crosses. It may be down here somewhere. This one's right on the x-axis. So there's basically two ways to name the asymptote. On this, what we're going to want to do is we can say the asymptote is y equals 0, or we could say the asymptote is the x-axis in this case. I like the y equals 0, but there is one other way that we use in calculus to represent an asymptote. You can say y approaches 0. That's what this symbol means. It says the y approaches 0. It's never going to touch 0, but it's going to get close to it. Never touch. And that's really all this lesson's about today. You're just doing the same thing over and over again. If you come in for lunch, you can use one of the graphing calculators if you're absent. You can also try to do these at home with a regular calculator to get your numbers there. Have a good day. See you tomorrow.